All right, good evening, everyone. Please signify if you can hear me. Okay, I want to believe that the hand raising means you can hear me. Yeah, so good evening, everyone. I don't want us to waste much time waiting for others. So I knew I would be busy today. That's why I suggested that we have this class early in the morning. But unfortunately, most of the participants were not open to that idea. So we had to do this evening, right? So yeah. Sadly, we have just 8 persons or 7 persons plus me, 8 on this call. Hopefully, more persons will join. More persons will join before we go far. So let's see how it goes. All right, yeah, so basically we are starting week 2 now. We're starting week 2 now. So what that means is we're going to be touching on this list of topics. However, I'm just going to switch it a bit. No, I'm not going to switch it a bit. Let's just leave it like this. But I'm going to touch. I'm not going to touch it in this order that it's in. I'm going to touch them randomly, right? So probably going to start from variables, then move into built-in types, then type conversions, then move into dynamic types, anonymous types, and nullable types. Hopefully, I'll try and go as slow as possible, and hopefully we'll be able to touch everything in the next 40 minutes or so, right? So let's see what we can do with this. So I'm going to share my full screen so you see what I'm doing while I'm doing it. Okay. Yeah, so I'm going to bring up the code that we're working with before last week. I'm going to bring up the code that we're working with last week, which is this Hello World app. So I would like to think that we now know how to create a console project. And then how to open it up in our VS Code, right? I would like to assume that. So I'm going back to the console project that we created last week. Or rather, let me not just assume, let me create another one. So I'm going to create a new one, .NET new console dashboard. I'm going to call this WeekTwo class. So I'm going to call it WeekTwo class. However, like I said last week, I have 3 .NET SDKs installed on my system. So that means that I have to force it to use .NET 5.0 SDK for this project or for this console app. If not, it would use the .NET 6.0, which is already installed on my system. So I'll show you that now. Anyways, it's creating that. So let's see, .NET /lists /SDKs. So I have this 3.1, 5.0, and 6.0. So to force it to use this one, that's why I added this other command. But since you only have 5.0, you don't need to type in this last command -f.NET 5.0. So I'm now going to go into that project that I just created using change directory cd week2 class. So I pressed tab to bring up the rest of the word there, right? So I could just type it completely, right? But an easy way to just get everything, just press tab, the tab button on your keyboard, and it brings up everything, changes directly into there. Then I would press code space period enter to open it up in our VS Code. So it's going to open up, great. It's going to open it up in our VS Code, and then we would have a console project already created for us, where we would have our program.cs like we had last week, and then our CS proj, and then our obj, and then we also have like a bin file, which will be created much later. We would also, okay, I'm going to zoom in a bit so that we can see what I'm typing. Just one more step, let's see what that looks like. Okay, I think this is fine, so that everybody can see what, before we start, I'm just going to, which is a step that I don't really need to take, but for the sake of, let's just try it out, let's run it. So we're going to run it to test it out. While that is happening, I'm going to bring up, let's see. I'm going to copy it, and then, wow, it's taking a while. Okay, yeah, so it's running perfectly. It's running perfectly, so we don't need this. I'm going to just minimize this for now. Yep. We're also going to drop in the topic that we're going to be working on there. Remember, I said that you're going to be getting this notification once you're opening up your project for the first time. Required assets to build and the yes, always projects. All right, so now I'm going to, okay, so this stuff is screaming at me because these are not conventional codes that was supposed to be typing. They're not conventional codes, that's why it's screaming at me. So I'm going to just comment it out. Comments are, let me call them codes that are on your, they're in your program, meant for developers, but they won't run even when you run the program, right? So right now, this text or strings, they're already in our program, but they're not going to run even when I run our code, because they're like comments that, okay, let's say I want to send this code to someone else and I want the person to know what I am thinking without me talking to the person. I could decide to just write a comment and say, okay, in this line, just add your code. So basically, when I do .NET run, all of this stuff would not run. They're just going to be there for whoever is reading it, right? So it's just a statement in your code, but won't run when you run the program. Anyways, we're going to touch more on comments maybe later on, but for now, it's just so that you have an idea of what's going on here. So I'm going to remove this. I'm going to start with variables in C#. All right. So variables in C#. Variables are like they are containers. Or let me just use this example. So they are containers that are used to store a value. So you probably have a bucket or a box of clothes, or a bucket that you use to store water or stuff like that, right? So those buckets or containers could be your variables. And then whatever you're storing inside would be values, right? So you're storing them in those containers such that you could probably use them later on. And that's what variables are. So you're storing a variable so that you can now use that variable later on, right? And how do you create a variable in C#? All you need to do is the data type. This is also going to shout at me because this is not conventional code. So ignore it for now, but just listen. Data type, then the next thing you want is name of variable, then an equal to sign, and then the value, right? So like I said, it's screaming at me because this is not conventional code, but this is how you write a variable, right? The data type, and we're going to be touching on data types today, built-in types, right? We're going to be touching on them today. So that's why I wanted us to touch on variables first, because it's like they go hand in hand, built-in types and then variables in C#, right? So you need the data type first, then the name of the variable, and then the value. So let's use our human scenario now. You have a bucket, right? And you have water in it. The water would be the value, right? Then the bucket would be the name of, or whatever you're calling your bucket will be the name of the variable, right? So probably you have a roommate and you're like, okay, the yellow bucket's in the bedroom, right? So that yellow bucket would be, the yellow will probably be the name or the identifier of that bucket. The identifier of that bucket. Then the bucket will be like the data type. So there are different containers in the world. You have buckets, you have bags, like I said, you have wallets, which you're using to store stuff, right? So now the identifier is what you now use to tell someone, this is what I want you to go get. That black wallet, black there is the identifier of that wallet. That box that has a wheel, that's the identifier or the name, right? So that's like the whole idea behind variables. Now we're going to, I hope I'm not too fast. So now we're going to now touch on built-in types, which we would now use to spell out our first variable. I'm going to comment this out so that at least we can say it as we go. So built-in types now. So like I mentioned, you have different containers in the world. You have buckets, you have bags, you have wallets, you have, even your house could be a container that's used to store your items, right? Bus, vehicles, airplanes, like a large number of containers, or this particular drug is this particular carton is a container housing whatever we have inside of it, right? So basically, this is, let's say, a built-in type, right? So in this case, C# have what you call built-in types or data types, which is like what I just spelled here. So we're passing data into our system and we want to identify them using different types, right? And some of the most popular data types that you want to, at least you want to be sure of is, one of them is string, that you need to know anyway. Some of the most popular ones, one of them is string, another one is integers. We have decimals, we have Boolean, we have characters, and a lot of a host of them, right? So now using string, let's declare a variable. Our data type, remember, is string. Sorry. That's our data type. Then the next thing is the name of the variable. And I'm going to call it my name, right? Then the next thing is equal to, and then the next thing is a value. Now for strings, you need to use double quotes to specify that this is a string. And my name is Gabriel Emmanuel, right? So this is our first variable that have been declared, right? So now the variable, this my name is the identifier for this container, right? And I can now use Gabriel Emmanuel wherever I want to use it, right? So let me show you what I mean. If I write my name to the console, previously, or let me even do this. Okay, so this first part, we have hello world. The second part, we have my name. So what is going to be printed to the console when I run? Let's see. Great. So for the first one, we have hello world printed, and that is what we wrote inside our console right line. However, for the second one, even though we wrote my name, what is printed is Gabriel Emmanuel, right? So once it got here, it noticed that, oh, there's no quote around it. So that means that this is a variable. Now it's going to check inside of the variable to find out what the value of that variable is, and that is what it's going to print in the console. So instead of printing my name, it's going to print Gabriel Emmanuel, which is what is the value here. So it's like you're telling someone, go get that wallet, take whatever is inside the wallet, right? Now the person is going to get the wallet, opening the wallet and taking what's inside the wallet, right? So I can now use my name multiple times. And that's another advantage of variables. I can use my name multiple times without typing Gabriel Emmanuel, and then it would print my name multiple times. Instead of my name, to print Gabriel Emmanuel multiple times. So that's another advantage of variables. You can now use it multiple times. So if I wish to make a change to my name, probably I want to add my nickname. All I need to do is just add it in this place, and then it's going to take effect in all three places. Instead of, let's say if I add Gabriel Emmanuel, Gabriel Emmanuel, Gabriel Emmanuel. If I wish to change my name in these three places, if they were just strings, I'm going to need to add Gabriel Emmanuel, code is here, code is here, and code is here, right? So that's another advantage, right? You don't have to now change things in multiple places. All you need to do is just change it in one place, and then it's going to take effect wherever you're using it throughout your app. So that's how you declare or initialize a variable. And string is also our first data type or built-in type that we've discussed. Now, another data type or built-in type is integers, right? This is used for numbers, right? I could say int, then remember the next thing is the name of the variable. In this case, I can use my number. And another thing to note is the name of the variables does not have to follow this naming convention that I am using, right? You could decide to use something else. You could decide to use, instead of my number, you could even say A as the name of your variable, right? Just know that, okay, once you're using A and you want to call it, you have to call it with A. You could say A, B, C, D as the name of your variable, but once you're using that, you should call it with A, B, C, D. But then, if you want to, once you're working with codes and you're calling or you're naming your variable, you want to give it a name that once you see that name, you know what is, you at least have an idea of what is inside that variable or what the value of that variable would be. So like, I wouldn't store water in a wallet. Neither would I store money in a bucket, right? So I can't say my name and then store numbers in my name, because when you're saying my name, someone should know that, oh, you're actually giving your name. Or when you say my age, someone should know that, oh, you're actually giving a number that is representative of your age. So that's another rule guiding variable naming, right? So once you're giving it a name, you're also finding a name that once you see that name, you have an idea of what you're storing in that variable, right? So if I say my age, I could just say, okay, store it as 29. But now the difference between int and string is that for string, I am storing, or I am wrapping it in double quotes, right? And then for integers, I'm not wrapping it in double quotes. So integers, it's going to have, it doesn't need double quotes. It just needs the number. So now I can decide to call my age, and then I can decide to run it to see what would be printed in the console. So we have hello world, which is this. We have Gabriel Emmanuel code is, which is this. And finally, we have 29, which is this. Now, what happens if I'm ignoring convention, right? I'm trying to store a string in an integer. And I try to run it. it throws an error. It says cannot implicitly convert type string to int. Can you see that? So it's telling me that I cannot convert a string to an integer. I cannot store a string value into an integer data type, right? Well, it also mentioned that cannot implicitly convert type string to integer. So this is important, right? Because we're also now moving into the next topic, which is type conversions, right? Because as you can see, it says cannot implicitly convert type string to integer. Right. So remember when I said that you cannot store water in your wallets, or you cannot store money in your buckets in your bedroom, right? So it's like the same thing happening here. I'm trying to store a string in an integer. C# would not allow that. That's the simple thing, right? I was thinking of a better way to explain it, but that's like the simple thing. C# would not allow that. However, it allows for some data types to be implicitly converted to other data types, as you can see here. So it tried to, it didn't give any error now. It's supposed to give an error, but it didn't give any error, right? So what happened here is it tried to convert it implicitly, right? Without you trying to say, oh, I'm converting it, right? So it tried to convert it implicitly, but then it couldn't. And then it gave you this error. And it's saying, check program.cs line 20. It cannot implicitly convert this. Now, for type conversions, there are two types of type conversion. So there is the implicit one, implicit type conversions, and then the explicit ones. Just typing it out here. My internet wants to be acting up today. All right, yeah, so the implicit type conversions and then the explicit type conversions. Now, so when we say implicit type conversions, let me close this. I don't like that error screaming at me. So we've only touched on two data types, string and int. There is another data type, I'm going to change this back, called floats. What would I call this now? What name would I give this now? I'll just call it narrative 570.23, right? That data type, right? So what is happening is I cannot store this. So I'm going to say int equals this, right? Hold on. No. All right, so yeah, I'm going to run it now. Yeah, I'm going to run it now. I'm sorry that my system is a bit slow. All right, so as you can see, it's throwing a couple of errors. It says cannot implicitly convert type double to int, and that's line 22, right? Then line 23, literal of type double cannot be implicitly converted to float, right? So we're having the same error, and I'm going to, so what is happening here is saying that this is a type of double. Then I'm going to remove this. All right. Then I'm going to remove, or just comment this out. Also comment this 2 out, so it's not giving me that warning. So these yellow signs, they are warnings, right? Saying that the variable my name is assigned but its value is never used. So we assigned it, but we didn't use it, right? So that is why it's giving that one. So I'm going to comment that out so that it's not giving us any warning, right? Now I'm going to run it again. So let's see what's printed when I run this. Supposed to print this double. Awesome, right? So now I want to explicitly convert this double to an integer, because if I try to store it in an integer, let's see if it's going to even implicitly convert it. What I mean by implicitly convert it is without me telling it that, okay, convert, would it convert? So right now, this is our double data type, naira to dollar, but I want to pass it into this naira to dollar int, which is an integer data type. So it's like me passing this 570.23 into an integer, right? Remember, when I tried it, it gave an error. So let's see if it's going to give an error this time. This time, I want to print out naira to dollar int. So let's run it. So it says cannot implicitly convert it. Now, to explicitly convert it, I'm going to have to just wrap around it int, right? So it's now telling it, I'm the one now explicitly telling it that convert whatever is in this naira to dollar to an integer and then store it into this naira to dollar int. Let's see if it's going to now explicitly convert it. And then if it does that, what the value would now be. Good. So you see that there's no more error there. And then after explicitly converting it, it threw away the 0.23 that is ahead of it, or that's after the whole number, right? So you cannot store doubles in integers implicitly, except you now tell it yourself, I want to explicitly convert this double to an integer. And what that would now do is throw out all of the decimals ahead of the whole number, and then it would store the whole number in the integer, right? So that is explicit. Can you guys hear me?
Yeah, I can hear you now, but it keeps breaking.
It was breaking. Okay, give me a second.
But now
okay, so yeah, so we've done implicit conversion. I'm sorry, explicit conversion. Now, implicit conversion is, I'm going to use this. So there's another data type called float. There's like a lot of data type. The article or the website I dropped has like a list of all of the data types and what you can store in them, right? So there's another one called floats. There is another one called long. There's another one called decimal. So all of these ones are numbers, right? They are numbers data type, right? But they have like certain rules guiding them. So let's say for integers, like decimal is almost like double, right? You can store decimals in them. Long is like integer, but integers have like a restriction, right? They can only store to a certain amount of numbers, while long can store more than that. I think the same thing as float, right? So that is why you can implicitly convert integers into floats. So I'm just going to store this as A and then put my age in there. Then I'm going to store this as B and then put my age in there too, right? And I'm going to print in A and print in B, right? So let's see if it's going to throw any errors. Hopefully long would not throw an error. I'm sure float wouldn't throw an error, but hopefully long wouldn't throw an error also. So let's see what's going to happen. It's supposed to print in 570, 29, 29, great, right? So this is implicit conversion. You're not hearing me? Please, let me know if you can hear me, please. Someone just types that they can't hear me. Oh, that is because, Kelvin, that is because you've not, yeah, so you should be hearing me now. Let's see. Kelvin, are you hearing me now? Kelvin, are you there? Okay, yes, all right, great. So now you can see that we've implicitly converted integers into floats and long, and then we've also explicitly converted double into an integer, right? Yeah, so we've touched on variables, we've touched on built-in types, we've touched on type conversions. Now we have nullable types, anonymous types, dynamic types. So these three types, they are also data types. Are they data types? Should I call them data types? Yeah, I think I'll be right if I call them data types, right? But they have like their own functions or their own way of doing things. Let me put it that way. Or their own reason for existing, right? I'm going to remove all of this. Since it's in the video, you're going to have to watch the video to get them back. But I'm going to remove all of this, right? So the data types that I mentioned, I've mentioned strings, I've mentioned ints, double, floats, long. There are a lot of others, right? And there are like a lot of others, right? So imagine that, okay, you need to, write in the data types for every data type or every variable that you're creating. Like when you're creating a string, you're writing string, you're creating an integer, you write integer, you're creating decimal, you write decimal, right? So some people prefer writing their variables like this, spelling out the actual data type of that variable. Some people prefer that, while some others prefer just using one word for everything, and then C# will now decide what data type is in there. And that's where dynamic types comes in, right? So dynamic types can be used to store just about anything, right? My name equals Gabriel Emmanuel. Then dynamic, my age equals 29. Dynamic, Naira to dollars equals 570.29. This is not the actual conversion rate. I don't know what the actual conversion rate is. That's just what stuck to my head, right? So I'm going to be using that right now. So you can see that I stored strings in dynamic, in a type called dynamic. I stored ints in a type called dynamic, and I also stored doubles in a type called dynamic. Is this going to throw an error? Let's find out. Someone just said dynamic is sweet. Okay. So I'm going to put in my name there, my age, and then Naira to dollars. And let's print this. Let's see. Oh, shit. Also, okay, yeah, I spelled right line wrongly. I was worried. What happened? I spelled right line wrongly with small letters. Great. So you can see it didn't throw any error. It gave us our values, right, the way we put them in the variables, right? And as you can see, it's saying dynamic, right? But during runtime, so there's something called compile time and runtime in programming. There's something called compile time and runtime in programming, right? So compile time is when I type in .NET run, it's going to, compile time, sorry, is before typing in .NET run, while you're typing your codes, the SDK is compiling your code and figuring out if there are errors, right? So this is, let's see. What would be, okay. An example of compile time is this. Let's see, this, right? So without typing .NET run, it's giving me this error. This is a compile time error, right? Compile, let me spell it so that you know what I'm saying, because sometimes my tongue, I don't know what's wrong with it. Compile time errors. So this is a compile time error. So it's an error that shows even before pressing .NET run. Now, if I do this and run .NET run, trust me, it's going to give an error, even though it's telling me that there's no error in my code. Okay, it didn't give an error actually. Anyways, let's see. Let me do this instead, which was the mistake I made earlier on. So now there are no errors here, but if I run this, it's going to throw an error during the runtime. Runtime is after typing in .NET run, it's trying to run our project. Then it's going to figure out that there's an error here. So why am I explaining compile time and runtime? This is runtime errors. So why am I explaining compile time and runtime? So what is happening is during compile time, our code does not pretty much really know what is happening here. Dynamic does not pretty much know that, okay, I'm storing a string here or an integer here or a double here. But during runtime, that's when it's going to now figure out what data type is being stored there. So I can get the data type by using this command, get type. I think that's the command, get type. Let's see. I hope I remember this correctly. So dot get type should give us the data type of each of these variables. I remember the command correctly. Right, great. So yeah, so as you can see, the first one is a string. That's why it's saying system.string. The second one is an integer. That's why it's saying system.int32. And the last one is a double, right? So it's not saying that, oh, when I use dynamic, I'm trying to throw away the fact that this is a string or this is an integer or this is a double. C# or .NET still knows what those data types are. It's just not, we're not explicitly telling it that, oh, this is a string, this is a this is an integer or this is a double. Yeah, so that's an advantage, right? And someone says it will have limitations. Trust me. Yes, well, almost everything in programming have their own limitations, right? But that's going to be like a deeper topic, so you don't need to bother yourself about that. But then let me just give an hint of what the limitation might be. The limitations in this case might be that there are some scenarios where you have to implicitly tell your code what data type you're passing in, right? Or there are some situations where dynamic cannot really work. Then you have to, use their data type exactly as it is, right? So there is also another word that you can use. Dynamic is, a cool word, but most times if you check some programming base or code base, you wouldn't really see dynamic. You would see var, which is a word that is very popular in the programming space, which is short for variables, right? So imagine saying variable, my name equals string, right? That's another way that you can now explicitly say, I want to create a variable without actually implicitly saying this variable is of string or of integer or of double. We're going to come back to question and answers. So let me just flow my thoughts first before I mess up what we're going to come back to questions and answers, please. All right, so var is another word that you could probably want to use. And using var, you can still get the values. So I'm going to remove the get type to get the values. And I'm going to run it. So as you can see, still printed it without us saying string, int, or double, right? So basically, you could just do this too. However, some persons prefer to implicitly say string, my name, stuff. Yeah, but when we get to question and answer, we're going to talk more on those stuff. Yeah, so we've touched on dynamic types. Let's touch on nullable types, right? So nullable types, I'm going to remove all of these comments. Nullable types, imagine doing my age equals null. This would not work. This would not work. Why? Because null in itself is a data type, right? Which is different from integers, right? So we can't store null in an integer data type, right? So it's going to throw this error, cannot convert null to int. So there is a data type called nullable, and then, well, null means nothing, right? In programming, like nothing. There is nothing in that. So it's like you're having a cup, but then there is nothing in it. We have this container, but there is nothing in it. So that's null, right? So null is a data type that is really needed in programming. Well, you can't store null in an integer. So what can you do? You can say nullable of int my age equals null, and then this would work, right? So what is it? Before we go further, what is a scenario when you can say you want to use null at first, right? So you're declaring a variable, but you don't know the age of the, let's say the user. So in the first case, you can say, oh, null, that's nothing. And then when you get the age of the user, you can now store that in that variable. So first off, what that means is the value that you're storing in a variable in the first case can be changed. Just like you have a wallet and at first you have 1,000 naira in it, then someone removes that 1,000 naira and replaces it with 2,000 naira. So that means that you can change the values in your wallet. It's the same thing with variables, right? So before we continue, I'm just going to show you an instance of this, right? So let's say int my age is 29. And then 4 years later, I can now say my age is 33. This is possible, right? So I can change the values in a variable. And then when you're changing the values in a variable, you don't need to say int anymore because you've already declared the variable previously. All you need to do is just call the variable. It's now yours. All you need to do is just call it and then change the values in it. So what happens here, if I put this console.write line here, I'm going to remove hello world to make this neater. So what happens here is, at first, my age will be 29. You know, my age does not exist. Oh, yeah. Sorry, this is my age, not MH. Yeah, thank you, Jadi. Yeah, thank you very much for seeing that. That's nice. All right, so my age, not MH. Now let me run this. So at first, it's going to print out 29. Then the next line is going to print out 33. But then I'm printing out my age. So my age in both places, but one place is 29, another place is 33, right? So what that means is I can change the value in that container. I initialized it with 29. I initialized and declared with 29. And then later down the line, I figured, oh, okay, I'm no longer 29, I'm 33. I can do that. I can change the values in the variable. So why did I bring this up, right? So let me bring this out now. At first, I don't know the age, but then later on, I know the age to be 33, right? So I can store null in this nullable int, and then later on change it to 33. Let's see if that works. Can you see that? So at first, this line here, although there's nothing here, but what it's saying that there is nothing in the variable, the first line, which is line 20, right? So let me just do something so that we know that, okay, this is the line that was printed. Just ignore what is happening here. I'm going to explain it probably in a later call, but let's just use this to say that, okay, then this is line 22. So see that they are both being printed. So line 20 would be nothing, as you can see. Then line 22 will be 33, right? So at first it's null, then later on it changes to 33. Yes, Dion, concatenation. Yeah, so this is called concatenation. It's a big grammar that means I'm adding strings to a variable, right? So this is called concatenation. And you could decide to research on it. Yeah, but like I said last week, if something is not, appearing to be, let's say, you're not understanding it, you don't need to beat yourself up. Just ignore it and focus on what, we're talking about, watch what we're talking about over and over again. We'll get to this point later on. Don't worry about it. This is just for us to see that, okay, line 20 was also printed. Okay, so that is nullable types. Now, finally, we have anonymous types. Anonymous types, another thing that I also wanted to point out is sometimes people don't even type in nullable types. People just do my age and then store null in it. Let's see if it's going to work. And then, right? So it's more or less the same thing like using dynamic or variable to just, let's see, cannot assign null to an implicitly types variable. Okay, I guess we can also do the same thing here. Okay. Let's see. Would it work with dynamic? Let's see. If it doesn't work with var, it's probably not going to work with dynamic. Well, it did work with dynamic. It didn't work with var, but it worked with dynamic. So yeah, you can store null in dynamic and then later change it to an integer, right? So let's see what's going to show here. Get type and the same thing here. So let's see what the types would be. In the first place, the type should probably be null, and then second place inf. But let's confirm. Oh, cannot perform runtime binding of null. Yeah, so probably I can't check the type. I can't check the type. The null reference. Yeah, I can't check the type here. But then, yeah, I can check the type. So let's ignore that for now. All right. So I'm just going to go back in time to okay, so now lastly, it's going to be, yeah, so like I said, you don't have to store all of this in your head, right? I actually had to prepare for this call before taking the call. So some of these things are not really in my head before like this week, right? Although if I need them, I know how to get them, right? But they're not really in my head before this week. So you don't have to like bother yourself about storing it in your head right now. Just understand what is happening, what the flow is. Then during the week, you can now do more research, practice, and practice and practice to at least have an understanding, right? Like I said, muscle memory. Once you continue practicing, you understand it better. But right now, you don't have to bother yourself too much about storing it in your head. Because for some of us, it might be faster, for others, might be a little bit slower. So, yeah, that's an advice I would probably like to give you right now. So, anonymous types. Anonymous types. Okay. Let's see. Give me a second. I want to figure out something about this anonymous types. Yeah, so I actually wanted to figure out what the data type would be. So let's see. var. I'm going to call it like the name implies now, anonymous, right? So it's like it doesn't have a type, right? It's just anonymous, but it's declared. Let's just declare it to see what is happening, right? So anon type, I'm going to call it anon types. I'm going to say equal new, then curly braces. So these are called curly braces. Then I'm going to, at the end of it, put a semicolon to close it. Then I'm going to say name. So that be, what name would I give it now? Name will be equal to, let's just say anon types. So I can give it any name, but I can say anonymous. Oh yeah, anonymous is fine. Comma, then projects. I'm gonna call this projects equals. We'll give it a string of .NET. Then version. I'm gonna give it a version of integer. So I'm gonna give a version of 5.0. I think that's fine, right? So this is an anonymous type, right? The use case for this is really rare, right? I think I've been programming for about 2-3 years now. I've not for once used this data type, right? This anonymous type. I've not for once used it. So the use case is really rare, but at least you probably would need to know that, okay, this exists, right? So how can I, find out what is inside my anonymous type? Should I just type in anon types? Let's see. This wouldn't work, but let's just run it to see what error would be given to us. Oh, okay, it did work, but it called out everything, right? It worked, but it called out everything. Yeah, my bad. So like I said, I haven't actually worked with this before now. So, but okay, now that it called out everything, let's run it again. Now that it called out everything, what if I just want to figure out what the version is? Instead of calling out everything, what if I just want to figure out what the version is? There's something called dot notation, right? Dot notation. So you use dot notation to figure out what a particular value is inside of an anonymous type, right? So like I said, I wanted to just find out for version, but let's just find out for everything. First one is name. Second one is project. Then lastly is version, right? So this is what we can now use to specify each of the value inside of an anonymous type. Okay, anonymous type, right? That's how it's pronounced. All right, so like you see, name anonymous, projects, .NET, version 5, right? So that is how you use an anonymous type. I'm really not going to beat too much into it, but this is how it's done. You can also read more on it in the article that is dropped. And then if you have any questions, you could let us know in the channel. So yeah, we've touched on almost everything we've touched on everything for this week. We've touched on variables, built-in types. We didn't touch on all of the built-in types. I think about 5 or 6 type conversions, that's implicit and explicit, nullable types, a situation where we can now can store null as a value in a variable. Then anonymous types, which is what we just talked about. Then dynamic types is the one we touched on earlier on, right? So we've touched on everything. So I'm going to end in the call now, but I'm going to start it all over again for our question and answer session, right? So just join back so that we can now have our question and answer session. But I'm going to end this call now so that after joining all of the videos, then we're going to be having just the class in a video. Thank you very much, everyone.